All right, this is grade 6, unit 1, lesson 5. And in this lesson, students are going to be playing with some parallelograms. We're going to focus on parallelograms right now. And they're going to be cutting and slicing and dicing these parallelograms in search for the official formula for finding the area of a parallelogram. So let's get started. All right, so here it says each parallelogram has a side that's labeled a base. You know what it should also say is each parallelogram also has some dotted lines because we've got some examples of bases and heights, and then we have some non-examples of bases and heights. So the wording is a little not clear, but here what we're going to do is we're going to look at some examples of bases and heights. So here's our base, here's our height. Here's our base, here's our height. Here's our base, and here is our height. So we're kind of outside that parallelogram. And then here's our base, and here's our height. So these are all examples of correctly drawn bases with their corresponding heights. All right. Now over here, some non-examples. Here's what they're identifying the base. Here's their height. Here's their base. Here's their height. Here's their base, here's their height, and lastly, here's the base, and here's the height. And so if we wanted to talk about, well, what's going on with the base and the height, let's select all the statements that are true about bases and heights. So it says only a horizontal side of a parallelogram can be a base. Horizontal side of a parallelogram? No, because here is a base, but it's not horizontal. So that's not true. It says any side of a parallelogram can be a base. Well, the answer is true. That is a true statement. Woohoo, true. And here's why. Here's our examples. They really did their best to try and show that you can have a base here on any of the sides of the parallelogram. They're really trying to show you the variety of ways of thinking about it. So this is a true statement. Then D, a base and its corresponding height must be perpendicular to each other. Now here's the beauty of it. All right, now let's take a look at these. If you look at these shapes of the base and the height and the way those two lines interact, you could see that the base and the height, they form the letter T. Base and a height right here, they form the letter T. Here's the base and here's the height. They form a letter T, and this base and this height form the letter L unless we extend that base, the line of that base, and we could see that they form a T. So 90-degree angles, right? Those are perpendicular angles. And so I'm going to erase that. So you can clearly see that the base and the height need to form 90-degree angles, whereas these non-examples right here, this is not a 90-degree angle, nor is this. This looks close, but it's not. And this guy right here is hard to see, but if we slide that height down, we can clearly see it's not a 90-degree angle. So that statement, a base and its corresponding height must be perpendicular to each other, that is a true statement. A height can only be drawn from inside the parallelogram. Well, that's just not true because we have an example right here. So we're going to call that false. That's not true at all. A height can be drawn outside of the parallelogram as long as it's drawn at a 90-degree angle, and that is indeed true. That is a true statement. Boy, I'm not doing my color coding really well. I want green to be true, and I want blue to be false. That's what I'm all about today. Let's do some serious color coding here. All right, and then let's get that green. All right, so that happens to be true. And then a base cannot be extended to meet a height. Well, that's just not true either. So, that's just not true. So I'm going to call that false. And why is that not true? Because it's right here. We did it right here. So that's kind of the example. And here's the deal. The way you could identify your base and your height, right? First off, your base and your height, your bases have to be parallel. And then secondly, that height has to be perpendicular to both bases. All right, so if this is our height right here, as I slide it around, it is always perpendicular to this base and this base. As I drag that height around, it's always going to be perpendicular to both bases, even if temporarily you're not seeing it, if it's like outside like this, all right? So that's how you know you've got the base. It's got to be perpendicular to both bases, not just one of the bases. And you might need to slide that height around to show it, right? Okay, so here we go. 5 students labeled a base B and a corresponding height H, base and height. For each of these parallelograms, are all drawings correctly labeled? Explain how you know. So here we go. Is this base and height correctly labeled? Well, here's our base, which means this is also our base. And we can slide that height around, and yep, that is correct. So that is a smiley face. How about this one? Is this correct? Well, here is our base. Here they're identifying the height. We know that this is a frowny face because it's definitely not a 90-degree angle right here. How about this one? This one looks a little tricky. Here's our base, and then here's our height, and it appears to be, well, it's definitely 90 degrees because it says that little box down there. But as we slide it around, yep, it's perpendicular both to the top and to the bottom base. So that is a smiley face. Woohoo! All right, how about this one? Ooh, this gets a little tricky. So here's our base. Here's our other base. Let's do green. Let's do purple because that's what I selected. Okay, and there's our height. And we can see that the height is always perpendicular to both bases. So that means this is a smiley face. And then this one. So this is a little tricky because I don't see any dotted lines. But here's our base. They're calling this the height. And as we slide it around, we can see it's just not perpendicular right here. That's not perpendicular. So that's a frowny face. So as we move to the next activity, activity 2. So activity 2 is where we're going to really start to dig deep into that official formula. We're going to hunt for that formula. So we're going to identify the base and the corresponding height, record their lengths, and then we're going to find the area, doing whatever we need to do to find the area. So we'll start with parallelogram A. Now you might be saying, wait. A is not a parallelogram, it's a rectangle. Well, it's both. So we see that the base is 4. We see that the height is 6. So we're going to record those two. Whoa. We're going to record those two things. So our base is 4, our height is 6, and we can count that the area is 24 square units. So let's take a look at B. So B, the base is pretty straightforward. It's right here, and the base is 1, 2, 3, 4, 5. The base is definitely 5. Now what is the height? Well, we know we draw the height right here. And we know it's the height because as I slide it around, it's always perpendicular to the two bases. And I can see that the height is 3. All right, so we have a base of 5 and a height of 3. Base of 5, height of 3. And we have our area of 15. Now, how did I get my area of 15? Well, I can imagine right here, this triangle right there. I can see that triangle and I can cut it. I think this was either Tyler's or Elena's method, I can't remember. And we slide it over here and that forms a rectangle that has a base of 5 units and a height of 3 units. So there's our 15. All right, and so let's keep going. Let's take a look at C. Well, C has a base of 2 and a height. Oh, this is a little tricky. Here's our height of 3. Base of 2, height of 3. Now, how do I know that that's the height? Because it's it's perpendicular to both of the two parallel bases, right? So the base up here, right there, and then the base down here, that the line, this line right here, is perpendicular to both of them. So my base is 2, my height is 3. Base is 2, height is 3, and finding the area of this might be a little on the tricky side. So what you might need to do is you might need to look at the enclosing rectangle. So here's this entire rectangle right here, and this entire rectangle has a height of 3 and 1, 2, 3, 4, 5, 6, and a base of 6. So that's 18 units squared. But then we need to subtract out these two triangles that should not be there, right? They're not actually part of that enclosing rectangle. And I can see that I can slide it over here and I make a white triangle that is right here. Well, my drawing isn't all that perfect. Slide it. There it is. Now it's perfect. All right, and we made a rectangle that is 3 units high, 4 units across right here. So this is the 12 units that we need to subtract out, 12 square units, and that gives us 6 square units. So down here, our base of 2, our height of 3 gives us area of 6 square units. And so finally D. Okay, now the height cannot be this line right here because it's not parallel to this base, nor is it parallel to this base. So that's not the height. It turns out the height is right here because here is our first base, here is our second base, and then I can slide this height up and down, and I see that it's parallel to both bases. And so my base is 1, 2, 3, 4. My base is 4. My height is 2. So we could fill that in. Base is 4. Height is 2. And by now we're starting to see that the pattern, the area is 8. And so we could see that the formula is base times height. Take the base, multiply by the height. That gives us the formula for any parallelogram. So the idea is, in this summary, we're supposed to play with parallelograms. We're supposed to identify what is the base, what is the height, and that discover that the formula for the area of a parallelogram is base times height. So there you go. There it is. So let's get working on the homework now. So it says select all parallelograms that have a correct height and labeled for the given base. All right, so we've got a parallel height and base. We're good. So that's a star. We have a base and a height that are not, oh, did I say parallel? I meant perpendicular. That are not perpendicular, so this is a frowny face. All right, we have a base and a height, and we can see that that height is perpendicular to both bases because the other base is up here. And so we can see that that height and base are perpendicular everywhere we go. So that's a star. Woohoo! And then D, so here's our base right here, which means there's our other base because they're parallel, right? And then here's our height right here, and we can slide that height and see that it is perpendicular to both bases at all times. So this is a star. Woohoo! All right. So number 2, a side labeled B has been chosen as the base of this parallelogram. Draw the height. All right. Well, that's pretty straightforward. So here's our base right here. Here is our other base. So we know that our height has to be perpendicular to both of those lines. So it really doesn't matter where I draw it. Let's draw it right here. There's our height. And how do we know that that's the height? Because it is perpendicular to both bases at all times. So so it doesn't matter if I put the line here, the height, I could put it over here, I could put it anywhere, as long as I'm demonstrating that it is perpendicular to both bases. Find the area of each parallelogram. Well, we've learned that the formula, area is base times height. So we've got 4 and 2, so the area is 8 square units. Here's the base, 1, 2, 3, 4, 5, 6, oops, 1, 2, 3, 4, 5. The base is 5, the height is 2, so the area is 10 square units. Ooh, this is tricky. So where are the bases? Well, the bases are actually going to be here and here because the height is right here. And as I slide it, there is my height. That's my proof that that's the height. So the base is 2. The height is 1, 2, 3, 4, 4. So the area is 8 square units. All right. If the side that is 6 units long is the base, what is the corresponding height? All right. So they're saying that this right here is our base, which means this is our other base. So which number is the height? Well, once you highlight the bases, it starts to show up that the height has to be here because that's the only line that is perpendicular to both bases the whole time. All right, so it's the 4 that is the base. The 4 that is the height. Number 5, find the area of each parallelogram. So they're removing some scaffolding. Up here we have grids to check our work. Now down here, they've taken away our grid. Ooh. So the base is 9. The height is 4. So the area is 9 times 4, which is 36 units squared. Here, ooh, tricky. The base is 5. The height is 4. So the area is 5 times 4, which is 20 units squared. And here, they're not giving us any numbers because our answer is going to be a formula. So here's our base. Here's our height. So the area is base times height, B times H, and that's it. That's the formula. All right, number 6. Do you agree with each of these statements? Explain your reasoning. Parallelogram has 6 sides? Nope. Nope. Nope, 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 nope. Opposite sides of a parallelogram are parallel? Yep. A parallelogram can have 1 pair or 2 pairs of parallel sides. No. It's got to have 2. It's got to have 2. So that is not a true statement. All sides of a parallelogram have the same length? Not true. Because this is a parallelogram. They said so. And all 4 sides are not the same. So we know that that's not true. And all angles of a parallelogram have the same measure. And we know that's not true. How do we know? Because we can see, like right here, we've got a couple of acute angles right here. And then we have a couple of obtuse angles right here. So all 4 angles are not equal, but the opposite angles are equal. All right, now number 7. A square with an area of 1 square meter is decomposed into 9 identical small squares. Each small square is decomposed into 2 identical triangles. My goodness. What is the area in square meters of 6 triangles? Oh my goodness. Okay, so let's take this a piece at a time. It says a square with an area of 1 square meter is decomposed into 9 small squares. Okay, so here is our area, a square of 1 square meter. So that means this is length 1 meter and this is length 1 meter, because then when you multiply them, you get 1 square meter. So it says it's decomposed into 9 identical small squares. Okay, so boom, 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 boom. It says each small square is decomposed into 2 identical triangles. Oh my goodness. So each one of these is cut into 2 identical triangles. Got it. All right. It says, what is the area in square meters of 6 triangles? So now we know that the whole area is 1. And then so we can see 6 triangles. 1, 2, 3, 4, 5, 6 is equal to 6 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 6 out of 18, which simplifies to 1/3 square meter. Oops, I shouldn't call it units. I should call it square meters. 1/3 square meters. And actually, we knew that in a different way. We could have said, well, look, here's 6 triangles right here. 1, 2, 3, 4, 5, 6. That equals 1/3 of the entire figure. So we had a couple of different ways to show that the answer is 1/3. It says, how many triangles are needed to compose a region that is 1.5 square meters? Well, we know that the entire thing is broken up into 18 pieces. So if we need 1.5, so if 18 is 1 whole, then 1.5 is going to be 18 plus 9, which is 27 unit. Little triangle, unit triangles, right? So 1.5 is equal to 27 triangles. So how many triangles are needed to compose 1.5 square meters? The answer is 27. And that wraps up a wonderful adventure where we were looking for the official formula for the area of a parallelogram, which is area is equal to base times height, and that height is always perpendicular to the 2 bases. So that wraps up Grade 6, Unit 1, Lesson 5.